Alright, so let's get started. I think the first thing I wanted to talk about was assignment 4. The professor who wrote it gave a little bit more insight as to how he intended it to be implemented. So we'll just take a quick look at that, maybe like 2-3 minutes here. Again, you can implement it slightly different if you like. That's okay. So I know I gave one suggestion for it last class. Yeah, so there's two things I wanted to note. One, we have a visitor pointer temp here, and then they delete temp. Might want to be careful about that. You might end up having a problem where it deletes the visitor that's also in the array. Actually, I suppose the array is a copy, so that's fine. So I think my concern doesn't really matter there. Just make sure you're not doing this if this array was to be a pointer of pointers, which I'm about to do as an example later today. Okay, so that concern, I guess I need to look at the code. The other concern I had, or that he pointed out, was the actual going through the array and knowing when a visitor is checked out. So, if you were to, in your checkout, the visitor out one, you should say something about like freeing up the space. So don't actually do that in terms of like deallocation with the delete operator, because you will get random garbage at that visitor space, and you have to search for the name when you do the visitor out function, right? So if you've freed up a visitor previously and you go to check out another visitor, if that first visitor is one that you will encounter in your search when you're checking things, you'll end up doing a string comparison on something that you shouldn't really be accessing, and the compiler won't give you an error, but you might get an error at runtime. So when he says free up space, don't deallocate. He just said to like set something to 0. So if we look at visitor.cpp really quick, or visitor.h, I suppose he just said like set the age to 0 and use that as a sentinel, which I guess is fine. You might want to do that. And then the other suggestion I gave was just to keep track of like a count variable. Right. So I said keep a count for the visitor and keep a count for the staff. So I added an integer that does that, and I think that will be just an easy way to keep track of everything. So I suggest doing that still. But just make sure you're not deallocating the space. I guess he put free up, but by free up he meant like put something that signifies that it's not there anymore. Any questions on that? That's the only thing I wanted to mention. Okay, so I have this open. Is assignment going to be due? Right now I have it due as Friday, and I'm probably going to stick with that unless everybody's really struggling with it. I do think it's difficult, but I kind of wanted to try my hardest to get everybody, or at least our section, back on the same schedule as some of the other sections. Although we are, I guess, behind a class because of that whole Labor Day holiday. So, I don't know. If I change it, it'll probably be soon, but just expect Friday. Okay. So, I think there were a few things we just wanted to clean up with this code. Did anybody have any questions regarding the pointers? I put this code up on Canvas, and there's that diagram that we drew last class that is on the recording. But I can totally understand if anybody had questions with pointers, or any of the shenanigans we did last time where we moved the pointer around and then changed how we cast it, and that allowed us to do different stuff with the data. This is new stuff. There was only one thing I wanted to talk about new with regards to pointers before I moved on to something else. And that was, or I guess not necessarily pointers, but memory allocation. I wanted to bring up another way to do it that is the way you do it in C, and it's also available in C++. And the main reason I bring that up is because if you are a computer science major, you're probably going to take operating systems, and they use C in that class. And if you're like me, you got to that class and didn't know what the functions did, and it was kind of confusing. So I'm hoping to at least demonstrate it so that you're aware of it. Yeah, so there you have it. I mean, maybe you'll have to write in C some point in life too, so it can't hurt to know. So another way to allocate space is with two operators in C. So I'm going to create an integer pointer here, and this is just going to be an array. Let me zoom in a little bit. Hopefully that's easier to see. So I'm going to create an integer pointer called int array. Let's just go down a little bit. Alright, and so I want to allocate an integer array, let's just say. So the way we've been doing that previously is I would do something like this, where I'd say equals new int, and then I'd specify the size, let's just say 20. And that would allocate 20 memory blocks of integers, each being 4 bytes. Now the way that you do that in C is that you have to specify exactly how many bytes you want. So the way I would do that is with a function called Malloc. And Malloc is for memory allocation. That's what the name says. So memory allocation. So this will allocate some amount of bytes of memory. So remember last time we drew that diagram. Maybe I can do it again here. We'll let that open. Right, so I said when we do, let's say, a character array. So I'll say I have a character pointer called C pointer. If I did C pointer equals new character 4, then that goes and that says I'm going to go into memory, and there's some amount of memory cells each here, again with like some sort of address, 1, 2, 3, 4, etc. And then it says I'm going to claim 4 of those. Well, it would help if I actually wrote it correctly, but I'm going to claim 4 of those. So that would be down to there. That's 1, 2, 3, 4. And those are all part of this array now, and that's what they're going to be used for. So it just marks them as being used by the thing. Allocated, if you will. And then we said if this was a character, that would make sense. This would just be 4 blocks. But if I had a integer array, and I went and I made a int pointer called iPointer, let's just say, and I made iPointer point to a new integer array that was, let's just say, too long, just so I can fit it in. Then what that did was an integer was 4 bytes, we said last class, and a character is 1 byte. So while in this one it would just allocate 4 memory bytes in a row, this one would allocate 2 blocks of 4. So it would allocate these 4, and then 1, 2, 3, 4. I drew the exact amount that we need. Okay. And then, all of the other memory after that is unallocated. 0, 1, 2, 3, 4. So I guess the point I'm trying to make here is that C++ keeps track of exactly how big these blocks are, right? So this one right here would be integer 1, 2, 3, 4. This space would be for the int 0 or I pointer 0, and then these 1, 2, 3, 4 would be for I pointer 1. And it would keep track of exactly the size for you, and it would do that. Well, Malloc only allocates in 1 byte blocks, so it will only allocate one of these spaces per allocation. So we need to actually know what the size of an integer is and what the size of Boolean is and all of that stuff if we want to actually allocate the right amount of space. And even though I'm writing 4 bytes here, and that is true, that's not always the case over time. And that's just because computers, I mean, I don't know if it'll get bigger anytime soon in particular, but we resize data types in computers the more and more memory we get. So, back in the 70s or 80s, an integer might only be 8 or 16 bits. So like 2 bytes, 1 byte, depending on the size that the system can handle. So, yeah, that might change over time. So if you run your program somewhere else and you hard code it to be 4 like I did there, it's not going to work. So if I wanted to allocate an integer array, what I need to do is specify exactly how many bytes I want by specifying first how many of those blocks that I want. So consider if I want an array of 20, I'll put 20, and then I need to specify how many bytes are in each specific array. So there's conveniently to accommodate for different systems having different sizes of integers, or data types, integers, floats, that kind of stuff. We can say size of integer. And then the other thing to consider, you can see if I scroll over it, this returns a void pointer, which we talked about very, very briefly last time, but a void pointer is just the address itself, so it has no specific data type. And the reason Malloc does that is because it expects you to know what data type you want to turn it into. So it's just going to allocate the memory, and it's not going to say anything about what memory is actually pointing there, which is why the new operator in C++ is a little bit more convenient. But Malloc is kind of generic. So I make sure that I specify that this is an integer pointer, and that should fix it. It would help if I use the correct variable name. There we go. Right, so what this says is allocate some memory, allocate 20 blocks of memory, and then I multiply by the number of blocks, number of bytes that is, in an integer, and it will allocate that many bytes. Is that clear what that does? You can only allocate in blocks of 1, or 1 byte things. Okay. So if this is the alternative to the new operator, then the other memory allocation operator we had in C++ was delete, and that freed up space. So it should be a function call. There's one called free, and then you just give it a void pointer. So you give it the pointer, and because it's a void pointer, you can pass any other kind of pointer, and it will cast it for you, or coerce it, rather. So this here will delete space. So this is similar to the delete key. So those are just two things to be aware of, I would say. Again, I'm not so sure we're going to test on them, but I know other instructors have been trying to teach this in C++, or sorry, in CS 202 now. That way, if you are a CS major, you know about this before they just spring it on you in 370, and then you kind of have to wonder what it does without an explanation. Any questions on either of those? Okay, so I'm going to close that then. So I think that's about everything with memory allocation that we needed to talk about. So I wanted to do a new example, and then we'll see how long this takes, and if we have time, maybe I'll start the next section. This was marked down as being like a week that I'm supposed to talk about this, but I can't imagine taking that long. Especially because we've already talked about this a little bit already. So I have here, I wanted to do an example that was similar to the museum assignment that you're working on. Oh, at least we have a little bit of insight as to that. So what I've done here is I've created a person class, a visitor class, and a staff class. And really quick, let's just move this over really quick. Let's move this all to a header file just for organization's sake. So we'll create a header and we'll just call it person.h, but we'll store all three in there. I think that's okay. So let's move all of these classes. I'm going to move this too. This should be okay. And then just to make sure that string gets resolved, let's make sure we move that. I'm going to delete this. Cool, and then we will include person.h. Okay, so let's zoom in there. Right, so if you've already started on assignment 4, which I kind of hope you have, because again, I think it's kind of difficult, you're going to have a person class and then two types of people here, visitor and staff. And what I'm going to do today is, let's just say we're going to do something similar where we check people in, check people out, and we want to make it maybe a little bit more generic, and maybe we want them to do different things. So perhaps we'll just print what type of person they are, whether they're a visitor or a staff. So right now I've just done a few things in advance. I have an integer max here, and then I have a pointer of pointers to all of the people that we're going to create. So rather than keep a staff pointer and a visitor pointer, I'm just going to create one person pointer that points to both of them, just for the sake of keeping everything close together. And I'm going to do it as an array just as an example, just to remind you of how to do it, since that is the way the assignment does it. Otherwise, I would say just use a vector. That's totally fine. So we have a count, which is static, and that's just the number of people that have been checked in, and then this is an array of all of the people that have checked in, and again, it's static because I want that to be just there. I don't want it to be shared, or I want it to be shared. I don't want it to be separate across everything. Right, so let's make these private really quick. So we have a count of all the people and a name, and we're going to implement this, and I've already written the static stuff here. I don't know why that's a oh, that's a pointer. Okay. So let's say I wanted to write a function that prints the type of person that each of these people are. Now, I will call that void, and we'll just say print type. I wonder if it lets me get away with this. Well, I suppose not if I don't have a keyword. Let's just write it this way for now. And maybe we'll put cout person. So it will print person if we call this on a person. Now, let's just write the same thing in visitor and staff. So each of these are inheriting from person, so they should get this function along with a name and a count. So I might do something like void print type cout visitor. Let's put endline as well. I do want to copy this. And then we'll just do the same thing in the staff class. Just go down here and let's have it print staff. So maybe in the context of my program, I want to know exactly what type this specific person is, but I'm going to just store them as person pointers because it's kind of convenient to just have all my data together like that. So let's go in main here, and I have access to this array called people. So I'm going to set people 0. And normally I would write like an add function like we did last time with like the integer vectors, but just for the sake of the example, let's hard code it and just set it. So I'm going to make the first person a visitor, and that'll be fine. We'll just do it like this. Identify people, oh, sorry, that is from the person class, so I need that. And then we will go down here and we will say people sub 1. So we'll make the second one, we'll make that a staff member. Perhaps I do want to write an add function. Maybe that would be a little bit easier. For now, let's just say we already know there's going to be 2 people. So I'll do int I equals 0, I less than 2, I plus plus. And you should never ever do this when you're actually programming, but let's just be lazy. Okay, so we're going to, let's just say, go through this array that we created up to the second one, because everything after that is not set yet, so let's not access it. And then let's just call that function that we wrote. So what I'm going to do here is call people sub I, and then we will, did I misspell it? Identify people, oh, again, I gotta make sure I have this. And then I think I called it print type, was that it? Oh, you know what, it wasn't public. Yes, here we go. So let me make sure that these are public too. Okay. Now it should give me the option to call it. There we go. So let's go through all the people and print the type that they are. So what do you think this will print right now? So I have a visitor at the first position, a staff in the second position, and I'm going to call print type, and then I have these 2 functions for a person and a visitor, and then I have the person version of it. So you think it's going to print visitor staff or something strange? Visitor and staff, any other guesses? That might be right. All right, let's find out. So let's hit that, and you'll see that it printed person, which is super strange. And I agree with you. I would think it would print visitor staff too if I, didn't already run this in advance. So that's super strange. It printed person, even though it was a visitor and a staff. Now, anybody have any guesses as to why it did that? It has to do with the way C++ treats function calls like this. Why would it call person instead of visitor and staff? Right, yep. Specifically because, well, actually, not because of this part, but I think you're on the right track. Because this people array was an array of person pointers. So what C++ does is, unless you specify otherwise, it will call the version of the function that has to do with the data type, even if you specifically didn't declare it as that type. So even though it's a visitor and a staff, because it's pointing to it as a person, it will interpret it as a person, and so it will call the person function for it. Which I would think it would print visitor and staff as well, because most other languages will do that automatically. You have to do it explicitly in C++. And I think I might have accidentally wrote it in an example that I uploaded to Canvas a while ago. So the way we get around that is we put the word virtual. And what that basically just says is it will, when it goes to call it, it will automatically override it with anything below it. And in fact, if you write this in any other language, if you wanted to implement the virtual function, you actually need to put the word override. So now what it will do is when it says virtual here, it will go and it will look for the one that actually matches the correct type. So if I run it now, it should actually print visitor staff. Yeah, which it does. So when I call it virtual, rather than base it off the type that it is with like a pointer, or whatever class type it is that might be above it in that tree that we draw, the class hierarchy, then it will actually go and look up anything below it.
If there's nothing below it, it will then use that. It'll just use it. Would say there was nothing. Omitted the one from staff. It would then print visitor person. Correct.
Yes. Oh yeah. I get what you mean. Yep. Exactly. So I think if I understand your question, so if I was to like just not do that, right?
That's correct. Yep.
Yep. So yeah, good question. So if I print it now, it should print person here, right? Yeah. So if you don't implement anything, it will just find the lowest one in that class hierarchy. So I could keep inheriting like 3 or 4 times, and if I implemented it only 3 classes down and I wrote 4 classes worth of inheritance, it will just pick the third one down. Yeah, so actually that's a good question. I totally spaced on that. Thank you. Does everybody understand what just happened there? So if I don't write anything, it will just it will go and use the virtual one anyways. Right. So this is useful when you want to overwrite something, or if you know you're going to do something like this, where you're going to have a generic like type that's higher on the class hierarchy that you're going to be using to store it. So in this case, I had person. Maybe I'll pull it up here. With the example we've been doing the past few weeks, I have that game object, and that would be another example. I would probably have a lot of different game objects in a game, where some are enemies, some are players, and then even then maybe I need enemies and then specific versions of those enemies. So I might have like an enemy pointer that points to all the different enemy classes. And then I want them to do something different, like in the function for the player update, maybe I want it to handle the controls and some different kinds of physics and stuff like that, state handling. Whereas the enemy maybe just has to like walk left and right or something, and that's all its update does. So when I write virtual, it will know automatically to call the right version of it, which is very convenient. So let me see if I still have this here. So I think I actually wrote this into the game, but I just kind of left a comment on it on the website. Yeah, so we go through the objects array. So just a reminder of what we had for this program that we wrote. We had like a game object vector here that held all the active objects in the game, and that included the player, which was pushed back, and the enemy, which was pushed back. And I had to do those as pointers to get around something anyways, so I did do that before we went over pointers, but that was just kind of because I had to. And then down here we went through all of those objects that have currently been added to the game, and we updated them. So we called whatever function they do every single frame of the game. And so you should see, I should have written virtual right there. So we have virtual void update for game object. So basically what I had written was that the player and the enemy have the ability now to override that without explicitly requiring the type to be mentioned. So I don't have to say, like player update. I could just say update, and it will say, oh, even though it's a game object, I know this game object is specifically a player or specifically an enemy. I'm going to use the one that belongs to that object. Everybody clear on what a virtual function does? I think that's really all I have to say on the matter. Very useful. I do use these quite frequently. They are super nice when you know everything's going to share the same function but not going to use it in the same way. So I guess maybe that visitor in person example, just because I'm going to leave it here, maybe aren't super helpful for the assignment, but they are there. So the other thing that I guess I'm supposed to talk about with virtual functions is abstract classes. And that's a little bit weird in C++. I think C++ 11 or 13, maybe 11. Let me find out. I feel like a certain version of C++ added it in. No, they did not. Okay, I'm wrong. So they haven't actually added this in. It's more of just a concept in C++, but no Java and C Sharp both allow you to specifically write the word, and it will just do it for you, which is nice. So an abstract class is a class that I don't want to ever specifically instantiate. And what I mean by that is, in the context of our game here, it might make sense for me to put a player in the game, and that's a game object, and an enemy in the game, and that's a game object. Maybe it's a good idea if I write this down. So I might create a player, and that is a type of game object, right? It inherits from it. And you know that has all the stuff that it needs. And then I might create an enemy, and that is a game object as well. So these both inherit from a game object, so they are game objects, and as such I was able to put them in that vector of game objects. But in the context of my game, I don't think it would make a whole lot of sense to make something that's just a game object, because I don't think that's specific enough. You know, what does it mean to be just a game object? Well, you know, you have a position and you know, maybe an ID, but you know, you don't necessarily have code that makes sense for you to have as just like a game object. In the same way that in the museum example, if I had a person, a staff, and a visitor, it might make sense for me to make a visitor object or a staff object, because a person is a visitor or a staff, but you never say that a person just entering the museum is just a person and that's the only identifying feature that they have, right? So if I don't want to make an instance of that thing ever, or it wouldn't really make sense to, then that's what we call an abstract class. So in this case, I would say that game object and the, let's just put a little star here, the person class are both abstract classes, and that they can contain a bunch of things that I need to be implemented in later things. So in the, I put player, person from the museum class, or museum program. Those are both abstract in that I don't want them to be made, but I still want them to be there because I want to inherit from them. So it's useful for me to have a game object class that has an ID and an update and stuff like that, that I can then borrow to write something like the player and the enemy. But it is bad for me to instantiate it itself because it doesn't really make sense to use it just, you know, as it stands. Now static, that's fine. We could use the static things. But anything that would require an instance, so I don't want the ID of just some random game object. I don't think that would make a whole lot of sense to do. So C++ doesn't have the keyword abstract here. Actually, I guess another thing to mention is you might also call these interfaces, is another word you'll see thrown around for them. I won't use that word too much. Whoops. I guess I can move this back. These are interfaces. I don't use that word too much, but you'll see that some people do. If you go into like Stack Overflow or whatever, they'll use the term interface. So I just want that to be clear that they're talking about the same thing I am. It's generally an abstract class. And I think there are slight differences between an abstract class and an interface in other languages. In C++, I think they're considered the same thing. It's just whether you're purely doing definitions or if you have static things, I think it's then considered just abstract. Right, so I just looked it up, and I guess they do have a way to implement abstract functions as well in C++. So whereas an abstract class is one that I want to just be a definition and not instantiate it, an abstract function is one that I want to exist, but I don't want it to be called. So an example of that, I probably should have kept it open. Oh, I did. Good. So I kept this person one open. So maybe I never want this person function to be called ever. This one right here. I only want it to exist so that I know and remember that I need to implement it in the visitor and the staff. And maybe I want to require it, actually. I want to force everything that inherits from this to implement this, or otherwise it crashes the system or just doesn't compile in like a normal language. In fact, C++ should hopefully stop you from compiling this way. So again, in like another language, I would just write the word abstract, but C++ doesn't like that, so it won't take it. But if I don't want this to exist and I want all of the inheriting classes to be forced to implement this, I would do something like this. And apparently if you just set it equal to 0, which I didn't know until right now, that will mark it as abstract. So hopefully, if I was to cut this and delete it, hopefully if I was to compile it, it should get angry at me. Object of abstract class. Oh, so they do recognize abstract stuff. Is not allowed. Pure virtual function. Print type has no override. Good, so it does recognize it. Awesome, so this wouldn't compile. So what it's saying there is that I have a virtual function called print type that is not defined as abstract, which basically just means I need it to be implemented in all of the inheriting classes, otherwise it won't, compile to begin with. And the reason that is because if it goes to do this print type call, which is virtual, we said earlier that if you don't have a version here, so if I delete this staff version, we established that what would happen is it would go up and it would just call the one from the class that this is inheriting from. So when it doesn't find it in staff, it would say, okay, well, I'll go try the person one. And it would keep going up the tree until it reaches the root. But the root here is just person. So it would go up to person and it would say, okay, I'll call the print type for that one instead. I will call that because you didn't implement it for me. But in this case, I don't have it implemented. I have it set equal to 0, which is apparently the way that you say that you're not going to implement it. I'm not going to define this outside the class. I'm not going to do anything with it. When it goes up to look for it now, it sees that it's not defined and that you specifically said you weren't going to define it. So it has no call to do. And then really what happens? Like, who knows? Because it's not implemented. It could throw an exception, I guess. Some languages have like a no implementation exception. So like a divide by 0 exception, or like out of range or invalid argument, stuff like that. Those are all exceptions, problems that we encounter. Maybe it could throw something that just says it's not implemented, but then that crashes the program, and that's not very good. So the compiler will just say, hey, you have to implement it. And that's the advantage of doing an abstract type like this. So it forces me to actually write it, like we had previously. So that would be good for something like this, because, again, I don't want there to just be a generic person. So maybe it makes sense to make all of the functions for that to be abstract, and then force me to implement it when I create a new type of person, a new class for that. Any questions on that? Okay. So then if you have questions, please let me know. I think that's really all I have as far as abstract and virtual go. It didn't take me long at all. Yeah, I don't know why they wanted me to talk about that for a whole week. I don't feel like I can get a whole lot out of that. So let's see what topic we're supposed to cover next. Operator overloading. And exception handling. Okay. Let's talk a little bit about operator overloading. I can definitely think of an example for that. So let me, really quick, let's just close this stuff so I don't have 3 tabs of Visual Studio open. We'll create a new project. Okay. So something here. And I think the example I want to go with here is fractions. So let me just make a class really quick. Whoops. You have to put virtual in front of the function to make it abstract. Yes, to make the function abstract. Yep. At least in C++. In Java and C#, if you just put the word abstract, it will know. So it has to be virtual, and then it also has to have that equals 0, apparently, in C++, to specify that you're not going to declare it. Because if you just put the semicolon and don't put anything after it, it might assume that you're going to go outside of the class and do something like, this, whether it was print type. It might assume that you're going to do something like that. Okay, so let's, really quick do that. Class fraction. So I'm going to just create a class called fraction here, and I'm going to write int numerator. Int denominator. Hopefully that's how I spell that. Okay, so let's do something simple here. We have a class that has a numerator denominator. I'm going to hope everybody knows what a fraction is. Although I guess I should mention a fraction in math is just defined as having an integer top and an integer bottom. No square roots, no irrationals. It should always be real, or real and actually integral like this. What was I going to do? Oh yeah, let's create a constructor that takes into integers, and it just sets the numerator and denominator. Equals and denominator equals d. Okay, so pretty basic class here. It just has a numerator and denominator and a way to set them with the constructor only, and then this stuff is private, which I'll just put explicitly so we're clear on that. Right, so that's pretty easy. So maybe what I want here is the ability to actually do math with these fractions. And maybe print them as well. I don't know. I guess we'll do that. So right now, if I try to do it, so let's say just fraction 1, and we'll say that's 4/5. Oops. 4/5. There we go. So this is 4 over 5 as a fraction. Oh, I actually need to include class fraction dot h. So let's create 4/5, and then maybe we'll just do like 3/7 or something like that. So if I want to be able to do math with these right now, I might have to go and write something like, well, let's consider this here for a second. Oh, whoops, I should name this fraction 2. If I wanted to do something like create a third fraction that holds fraction 1 plus fraction 2, then I can't do this right now, right? Because what does it mean to add a fraction? Well, we know that, but the computer doesn't, because we haven't written anything that says what that means, and it's not built into the language. So as far as it's concerned, does that mean to add the two numerators and then add the two denominators? Does it mean to do nothing with the numerator and then keep the denominator the same? Is there something special we have to do? You know, like when you actually add a fraction, you need to get the denominators to be the same. It doesn't really know what that means when I say fraction 1 plus fraction 2, because I'm adding a class type, and you know, that's not very clear as to what kind of side effects that might have. Like, consider if I wrote person, like the last class that we had, person, person, and person, person 2, and then wrote person 1, person plus person 2, something like that, then that really doesn't make any sense. What does plus do there? Like, who knows? It's kind of up to you to figure out what that would mean. So with our current solution might be to do something like write a function. So I might write something that says like add fraction or something like that. And that takes in two fractions. Well, we'll just say F1 and F2. And then that returns a fraction. Oh, whoops. Let's write that up there. And then, for the sake of time, let's do multiply instead. So let me write multiply fraction. One fraction f2. And the reason I say this is going to save time is just when I add fractions, I have to find the least common denominator first, right? I don't know if I want to write that right now. I vaguely remember how to do it. I think we used Euclid's algorithm, and I think I remember how that works, but I'm just gonna wave my hands and say addition's a thing that we could do. Multiplication is pretty easy for fractions, right? Because you just multiply the top and multiply the bottom and you're done. So if I wanted to multiply two fractions, then what I might do is I might return a new fraction. So I would construct a new fraction, and I would say that the numerator is the first fraction's numerator, and that's times the second fraction's numerator, and then the second one here is f1 dot denominator times f2 denominator, and that's not going to work because I have these as private currently. So let's just move this to the fraction class. That way it's public and can access the stuff. Oh, it would also help if I actually wrote the whole thing. So fraction 1 dot numerator, fraction 2 dot numerator. Denominator. So hopefully that's clear what this is doing. It just takes two fractions. We say we want to multiply them together. In fact, I could probably delete this. Let's make this static. That way anybody can use it. So this will multiply two fractions, return one, and multiplication of fractions just means we multiply the two numerators and the two denominators. So I construct a new fraction where the numerator is the two numerators multiplied, and the denominator is the two denominators multiplied. So if I was to call that here, and just, let's also write another one really quick. Let's write void print fraction. And this will just see out numerator and then the division sign and then denominator and line. Okay. So let's just make sure that this works. So let me create another fraction called fraction 3, and I'll set it equal to multiply fraction, fraction 1 and fraction 2. So I'll multiply these two together. Should probably move the chat back over. There we go. So what we should get here is 12 over 35, right? And then we will say print. So we'll take fraction 3 and we will print that fraction. So hopefully we should get 12 over 35 if I did everything correctly here. Or we'll get a compiler error. Oh, add fraction returns nothing. Let's just ignore that for now. I didn't even write this. Yeah, we'll come back to that if we have time. And you'll see that it printed hello world because I forgot to delete it. And then it printed, after that, it printed 12 over 35. So that's good. It did 3 times 4 and 7 times 5. So the multiply seems to work. It returns a fraction that is the multiplication of these two fractions. And then print fraction seems to work. It just prints the numerator over the denominator. Okay, that's great. Why did I do this? Well, we said earlier maybe we want to be able to write something like fraction 1 times fraction 2, and then maybe have fraction 3 equal that instead. And that'd be nice to have, just in general. But with the way we currently have to implement it, we have to write a function that actually does that. Which is okay, but maybe this to you just doesn't look very pretty or easy to read. Or multiplication of fractions, maybe to you, it just looks nice and makes sense to look at it and see a multiplication symbol, and you think, yeah, okay, that makes sense. So what we can do is we can actually change the way the star operator, the multiplication operator, works, and make it so that it does multiplication with fractions. And that's operator overloading. So I'm going to go here really quick. I'm going to create a static. We want it to give the return type. So when you declare a operator overload, it's essentially like a function. You give any sort of modifiers that you want to throw to it. So I'm going to throw in static here just because I want it to be usable everywhere by everything. And then I'm going to say it needs to return a fraction. So the first two parts of that are always the same. So it's the return type and then any modifiers if you wanted it. So I don't necessarily need static here. And then you write operator to specify that you're going to overload an operator, and then the operator that you want to overload. And then, like a function, we need to give it parameters. So I'm going to say here fraction f1 and fraction f2. Non-member operator requires a parameter with class or enum type. And does. And copy this over really quick. Oh, okay. Strange error. I mean, it seems to work now. So now what I've done here is I've said I want the times operator when I'm dealing with a fraction and another fraction to do the same thing that multiply fraction did. Okay, so if I was to change this, so that fraction 3 equals fraction 1 times fraction 2. That's not particularly... No operator matches these operands. I declare it right here. Do I have to declare it outside of the class? It's probably not going to let me access these now. I might have to talk about friend functions if it's not liking this. Let's just, to get around this really quick, let me write two functions. Let me write int get numerator that returns the numerator. So let's write two accessors really quick. Let's just get the numerator and get the... Oh, you're sorry, yeah.
I looked it up really quick, and apparently you have to put operator symbol right next to operator.
Oh wait, sorry. I need to put what? Oh, operator next to...
Operator star all at one.
All at one? Let's try that, I guess. I think it works either way. Was it like this? Where did I even put it? Like that? Operator star. Oh, yeah, I wasn't even looking at chat. Still seems to give it... Yeah, I think if it does it space or no space, it still reads it the same. Assuming I have that right. I'm going to try moving it back really quick. I think what it actually is I think I need to make it a friend function. And then implement it outside. I don't think it likes it when I implement it in the body, but maybe I am doing something wrong with it. For the time being, though, and I'll look this up too in a moment. Yeah, let's just use the accessor, I suppose. Now it seems to recognize it, I guess, since I didn't put it in the class. So if I run it, hopefully it should do what we expect it to. 12 over 12. Did I not write this correctly? Oh, it does. Whoops. The get denominator returns the numerator. Okay, let's run that one more time. So it should hopefully return the correct thing now. Yeah, so you see 12 over 35. Cool, so that seems good. And I'm sure there is a way to do it from the class declaration itself. I'm pretty sure we need a friend function. I just don't know if I want to talk about that right now. I'll probably wait a little bit. Does everybody clear, I guess, as to what operator overloading does? So it allows me to write something like this, where it's maybe a little bit easier to see, like an inline operator here, where it's in the middle, like we're used to, and it allows me to write it. Now, let's say I maybe wanted to do some more things. So I could also write addition and subtraction and division and stuff like that. In fact, division would be pretty easy for us to write. I'll probably write that. Let's also write really quick. Maybe I want to be able to do something like this, where I write int x equals 4, and then oops, 4 equals fraction 1 times... Let's just actually do it this way. Let's not even write the x. So maybe I want to be able to do a fraction and a number. Maybe that also makes sense to me. In this case, A integer as a fraction is just that over 1, right? So I can do that also. And I guess the thing to consider here is I can make the multiplication do two different things with a fraction depending on what the arguments are. So really quick, what I'm going to do here is I'm going to do another operator, but rather than, actually it's going to return a fraction, but rather than take a fraction, f1, and a fraction, f2, I'm going to make it take a fraction and a integer. So when I do that, if I was to take a fraction times a number, then I would just multiply this by the numerator, right? So I would take the first fraction times x, and then the denominator would stay the same. Am I missing a parentheses? I am. So now if I run this one and I print it, so let's do that really quick. Fraction 4 dot print fraction. Then I want fraction 4 to be 4 times the fraction 4/5, so this should be 16 over 5. And we should hopefully see that when we run it. That is 16 over 5, yep. So I don't have to strictly make it like two fractions. And I don't have to just limit myself to only one type of multiplication or one type of use of that operator. So I can make this multiplication do a bunch of different things depending on what I'm multiplying it by. So if I wrote a class for like complex numbers, I could throw that in there and give it support with fraction as well. Or, you know, if I wrote matrices, maybe I could find a way to make the fraction store, or the matrix store fractions or something like that. Now the thing to consider here is I wrote this operator times fraction f1 in x. Is there something I missed as far as this goes? Is there something that might break in my program if I only write that? So, what if I was writing my program and instead of fraction 1 times 4, I wrote 4 times fraction. Now it doesn't work. Now it's gone. And the reason is because I said that this one was a fraction, then an integer. So the parameter calls are not commutative. And really, when I write this here, it is actually a function call. It goes and it calls this as the first operator, or the first parameter, and this one is the second parameter. So when I write that, it doesn't think it makes sense. So it doesn't commute it, and that's probably a good thing, because if I was to write, like, let's just say a matrix class, if you remember your linear algebra from like high school, then if I have two matrices A and B, A times B isn't always equal to B times A, right? In fact, maybe you can't even do it one way, because I can multiply like a 1/4 matrix by a 4/3 matrix, but I can't do the other way around because the inner dimensions have to match, right? What does the star symbol after return do? Oh, this here? That's a dereference. So that's if I had an easier example, I'm numb to writing it at this point. But if I wrote an integer pointer called pointer, and I did that, and then I wanted to set it equal to something, then the way I do it is I put a star in front of it, right? To dereference the pointer and get the value rather than the address. So same thing here is new fraction. When I construct it in C++, at least, it makes a pointer to a fraction, or a pointer to whatever class type you constructed. So I put a star in front of it to return the value of it rather than a pointer to it, if that makes sense. Yeah, that might look a little bit confusing when I write it in like a whole long line like this. Yeah, at this point I'm just numb to it. I'm just like, oh, okay, I'll write it. Oh, but anyways, yeah. So if I did want it to be commutative, then I actually need to write both directions. So I would have to write integer x and then fraction, and then make it do the same thing as the last one. So now if I do 4 times fraction 1 versus fraction 1 times 4, they'll both do the same thing. So this one does 16 over 5 as well. So yeah, just something to consider. You might have to write both versions of these, but you can write multiplication that takes a bunch of different arguments and still returns the same thing. Really, these are just a collection of functions that have a special name. So whereas I could have written that multiply fraction function that I had earlier and just used that, this is a little bit nicer to look at. And that's really the only reason we use operator overloading. It's just nice to look at. And the code is much easier to read if we do it this way. So it's just a nice little feature that most languages support. Right, so I think with the last few minutes, let me just do maybe one more example for this, and then we'll call it a day. So I have multiplication. I'm not going to write addition right now because I don't know if everybody wants to go over that math, and I kind of only vaguely remember it, so I'm not sure I would do the best job either. But let's write a... I don't even think I need this static. I'm not really sure why I'm putting that there. I moved that out of the class, but it seems to be fine with it, so I guess that's okay. Let's write one that prints. So this one's maybe not as common sense. I believe it just returns an O stream. So when I go to print something like cout, it actually returns the stream that it just finished writing to. So I'm going to do something called O stream operator, and I'm going to make it be this operator that prints things, and I'm going to have it take a fraction and then a O stream on the left and a fraction on the right. It doesn't seem to like that. It's probably because I'm not using namespace standard. Yeah, there we go. Now it knows what an O stream is. So an O stream, like cout or a file stream, also works for this. We can override it so that it returns one of those and that it uses an O stream to do something. So what I might do here is return OS, and then we want to print the fraction, so I would do something like fraction1.get numerator, and then this, and then fraction1.get denominator, and then line. Oops. There's that. So it should return 1, right? Can I be referenced? What if I just do this? Maybe I need to put that there. Oh, right. Return OS. Sorry, I need to do 2 lines. I'm forgetting. Why is it not taking that? Function basic O stream declared at line 60 cannot be referenced. It is a deleted function. I've done something off here. Maybe it's because I used namespace twice? Nope, I didn't. Why is it giving me that error? Declared at 60. This is declared at line 60? 60 of probably an external file. Line 60 of the OStream library cannot be referenced. It is a deleted function. Do I need to return a reference to it? Okay, that seems to work. Alright, we'll take it. I guess because it needs to be returned by reference as well. So what this does is it takes in the output stream that I want to write to, and then the thing I want to write to it. So the way I would write a function is I would, write a fraction is I would write the numerator and then the slash and then the denominator, and I'm going to put an end line there. So I write all of this to the output stream, and then I return that output stream that I just used, so that if I have multiple of these arrows, it will work. So really quick, let's replace this with cout, and then I will put fraction 3, and it should work now. So this one, when I override this operator, it will look on the left, and it will see cout is an O stream, and the thing on the right, fraction 3, is a fraction. So it will go and call this operator, because this is the operator being used, and these are the two arguments. So if I go and run that now, it should print fraction 3 twice, and you'll see that it does. So this first one is getting called by the operator overload, and then the other two are getting called by the print fraction that I had before. And now, so the reason I have this return a value is again, weird C++ stuff, is it keeps moving this operator stream along if I put multiple of these. So if I wrote something like cout fraction 3, fraction 4, one of these will return, so this will evaluate, it will print fraction 3, and then it will return cout. So consider that what I did here is I wrote fraction 3 and cout. So if I look at just this part, it's going to call this function with cout on the left and fraction 3 on the right. It's going to put cout here, basically, or at least like a pointer to cout, and then it's going to print the fraction numerator and the fraction denominator, and then it returns cout. So what happens after this call is done is, and this is the reason I return the O stream, is it's going to do all this stuff here, and then it's going to return this as cout. So this will all get replaced with cout once that function call is done. And that way I have like cout fraction 4, and it does it again, and so on and so forth if I was to add more fractions. So you'll see if I print it now, it should print fraction 3 and then fraction 4, which were like 12 over 35 and 16 over 5. Yep, which it does. Okay. So, and that might be a little bit hard to wrap your head around, but that's how we generally override output streams for printing. So now that's nice. I don't have to write a print function either. I can just use it with cout, and it just works like everything else. Okay. Any questions on any of this operator overloading stuff? Yeah, we only have like 1 minute left, so I guess at this point, if you have questions, feel free to ask. If not, I'm just gonna stick around for a bit, I guess. So go ahead and close this.